So, today we're going to be discussing cylinders. Now, before we do that, I want to briefly talk about what we've been doing in 2 dimensions, how it's going to apply to 3 dimensions, and something called a net. Alright? First things first. What we've been doing in 2 dimensions so far is finding the area, right? When we're finding the area, we're actually breaking the shape down into little 1x1 squares and counting all of the squares inside. Now, doing that manually always takes forever, so instead of counting them manually, we use formulas. But the reason we call it units squared is because we are counting up the little squares. The 2 also tells us how many dimensions we're moving in. We are measuring up and down and side to side, 2 dimensions. Now we're moving into a 3rd dimension. We've got up and down, left to right, and forward to back, like this. Instead of counting up little squares inside this shape, we're counting up little cubes inside this shape. And so, whenever we find the volume of something, we are going to have units cubed. That little 3 here means cubed. It also refers to how many dimensions we are in. Additionally, we are going to discuss what a net is. Specifically, today we're talking about cylinders. So I'm going to discuss the cylindrical net. All right. A net is basically a 2D representation of a 3D object. So if you could picture getting a 2-dimensional paper with this cutout, you can fold these little circles down and then wrap this flat rectangle around it and create the cylinder. So this is the 2D representation of the cylinder. This is the net of the cylinder. I'm going to be referring back to this net at multiple times throughout the lesson just to try and visualize what we're actually looking at and finding. With that in mind, let's go ahead and get into the notes. So, today we are learning about lateral, surface area, which measures the area of everything except for both bases. So, looking back at this net here, if I were to find the lateral surface area, I'm basically finding this rectangle portion here, the area of this part of my shape. If you'd like to see it on the cylindrical portion, it would be this smooth part of the cylinder is what we're finding. We actually have a formula for it. The formula is 2 pi radius times the height. Or if you don't have radius, you have diameter, you can do pi times diameter times the height if you prefer. The surface area is very similar to the lateral surface area. It's the same thing, except it also includes the 2 bases. So looking back at my picture here, instead of just finding the lateral surface area, I'm finding this plus the 2 bases, the area of every surface of the shape. The formula for that is actually very similar to the lateral surface area. All right, it is 2 pi RH, which is the same as the lateral surface area, plus I'm adding the 2 bases. So I'm going to say plus 2 of the bases. The area of the base, because it's a circle, is pi r squared. We could also change this around a little bit because this first part here is just the lateral surface area formula. We could use this version instead. Pi dh plus 2 pi r squared. But again, this 2 pi r squared is just referring to adding the 2 bases together. The last thing we're going to talk about today is volume. Volume measures the number of cubic units in the interior of a 3D object. To put it simply, basically, we're just measuring how much space the shape takes up. The formula is pi r squared times the height. Or, sometimes you might see it as big B times the height. This big B here refers to the area of the base. Anytime you see a big B, it refers to the area of the base. In this case, because I have a cylinder, my base is a circle. And so the area of the base would be pi r squared. With that in mind, let's try example number 1. So, example number 1. My lateral area is 2 pi RH. Well, I've been given the radius and the height. All I got to do is plug it in. 2 pi times the radius times the height. And the calculator spits out about 1,797. I'm sorry, my tongue got tied. The unit would be yards squared because I'm finding the lateral area. So the lateral area is 1,797 yards squared. The surface area is 2 pi RH plus 2 pi r squared. Now, you might notice, like we said earlier, the first part of this formula is the same as the lateral surface area. So instead of rewriting 2 pi RH, I could replace it with what we found the lateral surface area to be, 1,797. And I just add 2 pi times the radius of 11 squared. When I type that into the calculator, I get 2,557.26 yards, again, squared, because we're dealing with area. Last but not least, volume is pi r squared times the height. Well, we know r is 11. We know the height is 26. When I plug this all in, I end up getting 9,883.45 yards. And this time, instead of squared, we're cubed because we're finding the volume. We're finally in 3 dimensions. So we're using the 3 for the exponent. 9,883.45 yards cubed. And that's it. Plug stuff into the formula and let the calculator do the hard work for you. Let's move on to number 2. Now, if you want to try number 2 on your own, I say you pause the video and go for it, with one word of warning. I want us to consider this cylinder as standing on the bases. That way we don't make any mistake as to what is what. Here I have the diameter is 15, and the height is 9. Don't get it confused. With that in mind, if you want to try it out, go ahead. Otherwise, let's get into it. The lateral area is 2 pi radius times height. My radius is going to be half of 15. Half of 15 is 7.5. And the height is 9. Plug it into the calculator, and we get 424.12 meters squared. The surface area is very much the same, plus the 2 bases. So whenever I plug it in, I'm going to do 424.12 plus 2 pi radius squared. And when the calculator helps me out, I get 777.54 meters squared. Last but not least, volume is pi r squared times the height. When I plug it in, again, my radius is 7.5, and my height is 9. Now, something I've noticed a mistake today is people keep leaving off this square here. Make sure you include that, because that is important. When we plug that in, we get 1,590.43 meters cubed, because we are now in 3 dimensions. Volume is 3-dimensional, so we get the 3 there instead of a 2. All right, with that in mind, let's go ahead and try out the last one. Now, this is a word problem, so we're going to have to pick and choose things from the problem itself to help us solve. It's a bit more difficult, but not impossible. So, it says the surface area of a soup can is 51.84 inches squared. If the diameter of the can is 3 inches, find the height. Well, I'm given the surface area, so I'm going to start with the surface area formula. The surface area is 2 pi RH plus 2 pi r squared. And what I'm going to do is I'm going to replace the information it gave me in the equation, or in the word problem, with the part in the equation. So, for example, the surface area is 51.84. So I'm going to replace the surface area with 51.84. 2 pi, those are just numbers. R is the radius. I was given the diameter. So to get the radius, I've got to take my diameter and divide it by 2. That gets me 1.5. So my radius is 1.5. H, we don't know the height, so I'm going to leave it as the variable. Plus 2 pi, radius, again, is 1.5, squared. Now, this looks pretty messy, right? But let's look at it term by term. Notice this term here is just a series of numbers that are multiplying by each other. The calculator can help us evaluate this. 2 times pi times 1.5 squared. The calculator can help us simplify this into 14.14. Over here, this term, I notice I've got a 2 times 1.5. So I can do 2 times 1.5 is 3, and then drop down the pi and the h. And now this is looking a little bit more like an equation that's easy to solve. How can I move the 14.14 over to the other side? Well, I've got to do the opposite of plus, so I minus. That cancels that out. And I get 37.70 equals 3 pi h. Now, the question becomes, how do I get the h by itself? Here's how. We got to remember, this is 3 times pi times h. And to get rid of times, we need to divide. So I divide by 3 to get rid of the 3, and by pi to get rid of the pi. Leaving me just the h alone on the right side. 37.7 divided by 3 pi is 3.9999, repeating, which is about 4, and my unit is inches. So the height of this can is 4 inches tall. That is all. I hope it was helpful. Have a good day.